Hi everyone, and thank you, Mike, and everyone for having us as part of this, part of Climate Week. I'm just going to introduce the session of talks. I'm Kate Davies. Those of you who don't know me, I'm head of Hook Park, co-director of the Design and Make programme down at Hook Park, together with Emmanuel Vacruza. Having relocated, I taught as well here for about 15 years, intermediate and diploma and media studies. I guess broadly, I mean, we dovetail quite nicely, I think, on from the previous talk. We're going to address this big green circle. I'm going to click on here, broadly, and the AA Carbon Project. And following on, I suppose, from Carla and from Thomas and Selina, and it's been discussed at length through the week, you know, more than ever, there really is an imperative to build more with timber, for architects to engage more with timber. And to think about this, we really need to think about the forests. So the series of talks is titled 100-Year Forest, and broadly it's Wood Lab, the Wood Lab Research Project, and people who've been involved in that, past and present. It's a research project based down at Hook Park. It's made possible by the generous support of John Makepeace. And it's a project that, in its simplest terms, connects foresters, architects, and engineers in a project together to explore the potential of interdisciplinary thinking across the timber supply chain. Hook's forest is a relatively small working forest. My colleagues here will go into that in a lot more detail, and it supplies timber for the prototypes and one-to-one architectural experiments of the Design and Make programme down at Hook Park. And I think the opportunity of the AA owning a forest, which is a pretty weird thing for an architecture school to own, when you think about it, is that as a school we can really engage critically and creatively and in reality with an understanding of the landscape and ecology from which timber's sourced. A form of collaborative design thinking from sapling to building, if you like. And this crosses disciplines, obviously. And today we've got foresters and architects talking together in a kind of soup. Like, rather than distinguishing one discipline from another, we're actively trying to kind of have a properly interdisciplinary conversation. Where soil health and biodiversity of a forest is of equal, if not more importance, than the timber yield by volume of, say, a productive landscape like this. As we've heard through the week, thinking about architecture and design in relation to landscapes of material production, the source or supply of materials, the associated impacts on the environment, as a critical site of engagement for architects and designers is really important. So I'm going to just briefly introduce the speakers. So at the end we've got Finbar Charlson, former Wood Lab Fellow and architect at DRMM with a specialist interest in timber architecture. We have next to him Chris Sadd, who's the forester. He's been the forester at Hook Park for over 20 years. You won't like me telling you that, actually. Managing the Hook woodland and the harvesting schedules. And, you know, as you can imagine, he's fundamental to the integration of Wood Lab as a research project into its kind of future strategy implementation, how it might be implemented practically, what's the opportunity involved in this not being a theoretical project. Then we have Wyatt Armstrong, who's a design and fabrication tutor on the Design and Make programme down at Hook Park and is also involved in the Wood Lab research at Hook. And finally we have Kat Byrne and Jez Ralph, who's going to replace me on this seat in a minute, who are our Wood Lab forestry research fellows at Hook, working alongside Chris in collaboration with leading thinkers across the forestry sector. And they've been developing what we've kind of loosely titled the 100-Year Forest. So they'll discuss that in greater detail, but I just wanted to say something about that, the idea of that timescale as a framework for thinking. Obviously, forestry is, it's by necessity, long-term thinking, forestry thinking. 100 years is relatively probably short-term thinking for forestry. But what the thinking enables is not just a kind of pragmatic approach to resilient forestry management in a changing climate, which is critical, but it also offers something else, and that's a kind of scaffolding for the imagination. So the act of thinking through the century, if you think about that, actually is both terrifying and, in a way, liberating. So by integrating this very real, very immediate crisis, imminent timescales, into longer-term thinking, I think it allows a potential for something that absolutely has to be part of our thinking as designers, which is hope. And so the ability to imagine a better world is really fundamental to making it happen. Okay, I've talked too long, and I'm going to hand over to Finbar. Thanks.
Cool, I think this one works. I'd like to echo Kate's gratitude to the school and to John Makepeace for making the Wood Lab happen, giving us, all of us, time and space to think about these things. During that time, I was an inaugural fellow, and during that time I was also working London and Berlin-based practice DRMM, and I've since assumed the role as a research lead, carrying out a couple of externally funded research projects, including one for the Forestry Commission that I'll talk about. But the studio has for a long time had an interest in timber. Of course, carbon is part of that conversation, but there are many different reasons that are hopefully evident in the work why that would be something we'd like to do. We've delivered housing here in London, which is something very difficult to do now, given some quite stringent regulations, so-called hybrid structures. And it does lead on very nicely to the Swiss-Austrian examples, because the studio was really founded on this attitude of taking some processes, methods and literally the materials from Central Europe, Germany, Austria, bringing them to the UK. Hastings Pier is a project where we were interested in reused timber, so salvaged boards from a burnt boardwalk for cladding. Equally, we've been interested in kind of not only mass timber, but making use of the whole tree, a narrative that I think has been really exciting, really pursued better than anyone down in Hook Park as well. And we are designing continually, spaces for learning, spaces for working. We believe deeply and are increasingly looking for evidence for the, the physiological benefits that you might expect from so-called timber buildings. But this project was key to what this discussion's about, which is our first kind of foray into designing with alternative species, designing with, in this case, hardwoods. So in North America, there is a glut of tulip wood, which is reasonably equivalent to something like poplar, which we have here in the UK. I'm sure I'll be corrected by Jez and Chris on that one. But here we were asked to develop a novel structural system, and then that gave us the power, the kind of confidence to go on and use that in actual buildings. So we developed Maggie Centre up in Oldham, using the offcuts from the manufacturing process to design the ceiling. And hopefully a scheme like that also evidences, the ambition to use very diverse range of materials and species. This project we have on site in Berlin. This is made possible. It's a workspace hiding within a historic building envelope. The mass timber has allowed us to push all the structure to the outside and span very long distances using beech hardwood beams. So Baubucher, pioneering material, has allowed for some excellent strength to weight ratios and enabled some building designs that wouldn't really have been possible with timber otherwise, engineered timber otherwise. This project just finished down in southeast London, work stack building, cross-laminated timber, not especially novel in its use of material in terms of species utilization in the built fabric, because that's come from this Austrian CLT. But what's really nice is up in that top left unit, we have now One of the tenants is Japanese duo furniture designer makers, and they're finding that there's a great appetite for the use of urban street trees, diverse hardwood species in the work that they're making. And so things kind of came together actually whilst I was down in Hook, and in DRMM we were interested in progressing, trying to really progress our dialogue around the use of timber. So we'd produced this drawing that talks about the history, present and the future of forestry, as well as the history, present and future of timber construction, touching on resource extraction, utilization, and new emerging technology. And then off the back of that, we joined forces with a couple of other academic partners, Edinburgh Napier University and the New Model Institute for Technology and Engineering, BEST up in Scotland, and Ecosystems Technologies. And the government had a call to try and promote the use of more English hardwoods, because you can see in this chart on the right, what they were projecting is essentially a decrease in the amount of available softwood, and actually a concurrent increase, although not anywhere on the scale, but a concurrent increase in the available hardwoods. There is, of the standing of the biomass that we have available, there is a comparable, in England anyway, specific to this research, there's a comparable mass of hardwood to softwood, but we really don't make use of the hardwood, and in fact 85% of it that's harvested is just burnt straight away for energy production. So it's just, even before we get into all of the considerations that the rest of this team here will speak about, it just made good financial sense for the Forestry Commission to try and promote that. So there are a number of key species that we were exploring, wide range of engineered wood products stemming from different families of primary processing activities, some of which are compatible within the UK, within England specifically, and some of them simply aren't. We conducted quite a comprehensive market review, speaking to foresters, speaking to people working all along the supply chain, and realised that there is basically a pretty dysfunctional system, and there's a real appetite for more vertical integration, more distributed manufacture, so that many sawmills which are being forced to close down, they can add some more value to their products, and that they would like to make some more kind of higher value products, because as we saw actually in the previous slide, there's not a great deal of money to be made at the very beginning of the process, and actually if you can bring some of that manufacturing earlier on, then you can make a more compelling argument for making use of the material. So we're testing many different hardwood species. Professor Dan Ridley-Ellis has a fantastic setup where we're testing for torsion, bending, stiffness, and we're able to compare the performance of these hardwoods, all of them outstripping the performance of their, in terms of strength to weight ratio of softwood of the same biomass. Perhaps you won't be surprised to hear that. And also some evidence that the charring rates are a bit slow, which is very, very interesting as well, from research in the University of Edinburgh, from Angus Law. And so we're able to now narrowing down this tree, and we're getting to some of the products that we think there's a real appetite and potential to scale. We're taking on some kind of exercises to understand what is really unique about the hardwood compared with the softwood. Can we be a bit more resource efficient in the way that we're processing that material? And speculating on the potential for hardwood to potentially augment some of the softwood products that we're already used to. Is there a way that we can benefit from that enhanced strength and enhance that existing resource? This, for example, is a study into a process I termed additive lamination, whereby if you could be very efficient in some kind of peeling and cutting process, could you actually be looking at timber as less of a kind of cutting and carving process and more of a kind of more additive, resource efficient process, mixing species within the laminations, benefiting from their different mechanical or otherwise properties. And we're interested in trying to apply those species, where they're best placed. So there might be some which aren't especially strong, or which are just there on the outside of a beam to resist overturning. And those that are really doing the hard work, they might be in the center and be the deepest elements of the structural element. and ultimately just trying to look at the whole exercise as an opportunity not just to replace a material that's dwindling or try and simply add value to a product, but actually can this give rise, this diversity of species, this diversity of materials and their performance characteristics, can that give rise to a diversity of buildings and built forms in the environment? Thank you kindly.
So Finn is not only showing us that incorporating a greater species mix into architecture is possible, but that we'll be seeing a decline in the availability of softwoods and a rise in hardwoods. And one of the global drivers behind this transition in forests will be fire. First, we're going to look at how fire is made. So you will need a source of ignition and some tinder to carry the flame, to kindling, and fuel to sustain the fire. Finally, you can arrange the fuel evenly to promote good airflow. So simple steps in fire design, but if you follow these, you'll have a pretty good fire. And if you fail to follow them, you can pour gasoline on it. When we translate this to forests, the two main sources of ignition are human activity and lightning. The ratio between these changes depending on where you are on the planet, but in Canada, it's roughly 50-50. Lightning is going to get more common. A degree of warming in air temperature has been linked to a 12% increase in lightning strikes. And so once you have ignition, you need tinder, kindling, evenly arranged fuel, and good airflow through the fire. Softwoods are also full of resin, which is highly flammable, so a bit like pouring gasoline on a fire. And so you have fires. These are the fires in Quebec that blanketed New York in smoke earlier this summer. The term wildfire, as these are branded, is a bit misleading, as all but one of these fires are in industrial landscapes, not wilderness. The type of forest this campfire analogy looks at is monocropped, even-age stands of softwoods, which is the main source of timber for building products. That all being said, fire can actually be an essential component of forest ecosystems. Some trees are well adapted to fire, with others relying on it for reproduction. Mature trees are generally more resistant to fire than younger ones, and old-growth forests more adapted to fire than young plantations. These are coastal redwoods who will wait up to 20 years for a fire to assist in releasing their seeds. Red pine and white pine forests are adapted to surface fires that spread quickly across the ground, facilitated by their needles. Jack pine keep their low-lying branches to bring fire up into their canopies, which will kill them, but their seeds release at 350 degrees, so without fire to facilitate reproduction, they would be replaced by other species. Most of the fires we hear about are destructive, out-of-control burns, particularly ones that affect or burn their ways into communities. There are a few factors that lead towards these type of fires. The warming climate and drought are major ones. Another is the historic suppression of fire on managed land over the past century or more. If you grow something to sell, it makes sense to prevent it from burning down, but fire suppression results in the buildup of excess fuels that can cause even adapted species of mature trees to ignite. This region is just east of the Rocky Mountains in British Columbia, where even-age stands are harvested through clear felling on a rotating cycle. With newly planted plots, the trees haven't developed bark thick enough yet to protect the resins from fire, making them super vulnerable. And if we zoom out, this is that region this summer. And for scale, this is the UK. So basically Scotland is on fire and Wales and England are in smoke. When we hear about fire in the media, it's usually when it affects cities or travel plans It can be out of touch, but we hear less about the locations of fires themselves, particularly fires in the boreal forest in Russia and Canada, where the most amount of tree cover is lost to fires. These are a few fires in Alaska, Canada, and Russia, remote areas that are extremely hard to access and put out. The way we measure damage from fires is likewise centered around our welfare generally, measured in the amount of buildings burned, number of people evacuated from cities, or how many emergency firefighters are on the ground. Another metric applied is carbon. So this graph takes us to the end of July in Canada at 290 megatons of carbon released by fire. By the end of September this year, that number was 2,000. Ways to contextualize that large number are to compare it to Canada's emissions at just over a quarter of the fire's emissions, and global air travel at roughly half. 57% of those emissions were released on unmanaged land, 43% on managed forests. The fact that this ratio is close to 50-50 is concerning because managed land has clearly defined routes of access through each plot and fire management strategies in place. So we're working with the idea that we can work with forests to sequester carbon and store it in building products and use our buildings as a carbon sink. But this idea has a bit of a flaw right now because the forest type producing our building material is on fire and has become a super emitter. So what do we do now? There is actually positive news coming out of these burn sites. Black spruce is a dominant species in boreal forests in Canada and Alaska, and like sequoia, it also relies on fire to release its seeds. It's a very flammable species. The fires occurring in the boreal forest are moving past the point of facilitating their reproduction, and that forest type is changing. Over a 13-year study at 89 burn sites in Alaska, a succession pattern developed where 71% of the sites switched post-burn from dominant black spruce to a mixed forest with dominant deciduous aspen and birch, which are less flammable trees. These species store carbon at a rate 4 times faster than black spruce. And it's noted in this study that projected out over a 50-year time span, the succession trees could actually resequester the carbon being released now in the boreal forest. Similar succession patterns happen on managed plots. However, the incoming trees are not seen as commercially viable, and their growth is suppressed through chemical treatments to remove hardwoods from softwood stands. Mixed forests are being recognized now as natural barriers to the explosive growth of these fires, seen in more homogeneous landscapes. Mixed forests don't burn as well because of the mix of fuel types, densities, and ages of the trees. Basically, diversity is bad for fire, but very good for forests. So when we say we're working with forests to sequester carbon, we need to work at understanding what forests want to be and sometimes also what they want to become. So for this model to work, all of these industries really need to change. And I'm wondering if, as a community of people who specify building products, so like as is being done by Finn at DRMM, we could look backwards through this system to understand the opportunities presented by species diversity, to encourage a transition from even-aged monocropped forests to uneven-aged biodiverse forests. Pass to Jez.
Good afternoon, everyone. It comes to me to sort of provide a transition, I guess, from a global material and forest outlook to one that's more localized to Hook Park and the incredibly unique situation that the AA is in. And we, Kat and I, work for an organisation called Evolving Forests, and are working on the Wood Lab Scholarship. And we do that because of the uniqueness of the situation of not just being able to debate the future of materials, but to put that into practice as well. And I think that's something that's beholden on all the AA members to think about in quite a profound way. And so let's start by quickly just looking at what the global situation in relation to Hook Park's material provision and material provision to the UK. And we are the second biggest importer of timber in the world. We import 80%, between 60 and 80% of the timber we need in the UK, we import from elsewhere. And this is where it comes from, most of it from Scandinavia, but actually from all over the world, including large amounts that we ship from New Zealand via the Netherlands to be manufactured and into the UK. And I mean, for me, that's problematic in a whole load of ways, but one particular way I think that we ought to think about today is all of these places have huge inherent climate-caused problems. And so in the States and in Canada, huge loss of timber, not just to fire, but to insect attack, whether that be spruce bark beetle or the, quite frankly, ridiculously good-looking emerald ash borer that has decimated ash and will probably decimate ash here at some point as well. Whether it's destruction of Amazonian rainforest, drought in Europe, melting of permafrost in northern latitudes that prevents forest harvesting, or just the carbon miles associated with shipping timber from New Zealand. And every time we use a piece of timber in construction, then we have to think about these problems and what are what the implication of our use of those materials are in causing these problems. And that's sort of demonstrated for me quite well by the use of cross-laminated timber in construction. It's a very popular material for a whole load of very good reasons. It stores a lot of carbon. It's ridiculously easy to design and use. The problem is, though, if you want to use this, you have to buy in to the idea of modernist land use and modernist ways of doing things. This requires very large amounts of monocultural forestry, and we really have to ask the question of whether that's what we really want in the future. It opens all sorts of questions, not just about how we use land in the UK, but how we use land abroad, and as big timber users, what we are asking of other countries to provide us with this. Can we expect other countries to grow this kind of forestry for us if we're not prepared to grow it ourselves? And so one of the things we are trying to look at Hook Park, within the AA, at Evolving Forests, all sorts of people around the country, is how we can better use timber and how we can better use our forests. And that could be in a whole host of ways that we're experimenting with. Two things I'm particularly interested in is furniture making. I'm interested in how you can put a 100-kilo person on a chair with the most spindly of legs, and what lessons we can learn within architecture of those structural dynamics. I'm interested in how we can take timber apart to its constituent parts and not just the lignin and cellulose, but the volatile oils and oleoresins within that, and how we can better use them, and whether that provides a way of using poorer quality timber, of which we have vast amounts in this country. And I'm interested in how we can use different types of timber. Do we need to grow straight trees in big single species plantations, or is there an alternative way that is more ecologically sensitive to us? And how do we drive that agenda forward, not just for ourselves, but for future generations? And I think I'll just leave you with this thought before I pass on to Chris and Kat to talk about Hook Park. But we are now entering the tree planting season, and forests will be planted all over the UK over the next few months. When we make a decision about what to plant today, We are not interested in what you need as material. We're not interested in what the people sitting here in 20 years need as material. We're interested in what your great-great-grandchildren, what future architects in 80 or 100 years' time are going to need as a material. And I find that both traumatic and exhilarating a profession to be in, to have to make those decisions. And I think in the past, we as foresters have done that on our own, whilst you as architects have designed in a silo as well. And with places like the AA and Hook Park, there is now a chance for us to work together to make sure that what we plant and the complexity of forestry matches the complexity of future design. And with that, I'll hand over to Chris.
Hi. Yeah, the last two presentations have been a bit like reading a travel brochure. We've travelled from New Zealand to Canada and elsewhere, but I think it's important to remember that we are living in the UK at the moment, I think, and so let's concentrate on what we get up to in the UK. So if you go back to the first, UK forestry at pace. You know, I've been given 5-10 minutes, like the rest of us, to talk about a very wide-ranging subject. So let's take off from there, shall we? So once upon a time, all fairy stories start with once upon a time, but this isn't a fairy story, this is true. Okay, so once upon a time we had lots of just wilderness in the UK, probably 60% of the land was wooded. What stopped the wood from climbing upwards was probably the altitude only. And then we moved into, if you want, a next historical era, which was the landscape began to change when people decided that they needed food to grow. So we cleared the land for both arable crops and also to run our pigs across, and our sheep, probably mainly pigs, I should imagine, and oxen as well. Okay, and this just continued. It's interesting to note that we have an arrogance in this country and in Europe that we're telling everybody else in the world that they should stop burning woodland. You take the Amazon, for instance. But they're doing what we did 200 or 300, 400 years ago. Just if we take the image on the right-hand side, so it is showing you both examples on the one slide. So you have the agriculture there, the pasture land, and you have the woods that surround it. The interesting thing to note, and often this can be seen on maps, old historical maps, is there isn't a straight edge there at all on that photograph, which suggests that the woodlands up on the hill there probably came all the way down the hill at one time. Right? And likewise, the woodlands in the near view there. Okay, but then we finished up with what's on the left there. All right. So this is an interesting slide. It introduces sustainability. Okay, it's a word that's been around for millennium, and we as creatures, we are sustainable, and this is a good example of sustainable woodland management. Okay, so the system, next slide, we got it there, is what happened. So up until the late 1800s, this was a very common practice for several hundred years, where what you've got here is you've got two crops growing. Both of them are native to this country. We have, as a shrub layer, we have a hazel, which is unique in itself. The more you cut it, the more it wants to grow. And then above that, you have the higher story, which appears to me in this picture could well be, it could either be oak or ash. I should know it's either one or the other, but I can't quite make out. So what happens is it's very much a cyclical thing, and hazel would grow for 7 years and produce wood that was the size of my thumb, and from that you would produce products. Fuel wood, you would produce fences to enclose sheep and pigs. And then you had the higher story, which would be felled probably after 30, 40 years, where you had big enough timber to include in construction. Okay. So come the late 1800s, unfortunately the markets disappeared for all those uses that I have down there on the left-hand side, left corner, because shipbuilding, you know, we started building ships out of steel and iron, and there were new construction materials that were being developed all the time, and therefore wood took second place to these new materials. Right, so this is a map that probably our next speaker, Kat, will show us, but it's actually quite important to appreciate the fact that probably, when was this done, in 2018, total woodland cover at the time was about 12%. And we'll just run through the ups and downs of forestry cover in the UK. So pre-human influence, I'm going to call it that, probably 60-70% of the UK landmass was covered in trees of sorts. Okay, so we're looking at ash, oak, alder, lime, hazel. And then come 1086, yes, I'm quite exact with that date, because a book, which is called the Doomsday Book, was written. And that was really it was a huge survey of all the land and land holdings at the time. And at that time, 15% of land was covered, or UK was covered in woodland. Come the 1300s, it had dropped to 7, 1900s to 5, and suddenly, the present day, we're up to 12, 13%. Okay, and we're hoping all the time this is on the increase, but it's going to take a lot of hard work, I suggest to you. So I've sort of given you the impression, well, I have, that there is a constant, you know, the woodlands in this country have gradually disappeared. However, there are still signs that it hasn't quite disappeared altogether. And I've got 3 slides to show you here. The first one is this one here, to show you that, you know, we're still holding on to, you know, the golden times of woodlands. And this, believe it or not, is a 2,500, 3,000 year yew tree in Shropshire. So that's a long time for a tree to grow, and it's still in good heart by the looks of things. Okay. We then have the bluebell. Yeah. So I think a lovely image of the bluebell. That we have that at Hook and lots of other woodlands in the UK, and it's a good indicator of stability on that land. Okay, when you start seeing bluebells in fields or in hedgerows, that suggests to you that once upon a time that could have been part of a woodland. And then we have, finally, on an identifier, we have the wood anemone, which again is suggests stable land, old woods on there. Okay, that tends to propagate by underground roots, and you get masses of these things. We've got quite a lot at Hook. And then sadly, we, as Jez has alluded to, and so has the other speakers, is we come to what I'm calling the industrialization of forestry. which already began in the 1919. First World War just finished. We needed to rebuild our stock of timber, and so we decided the easiest way out was to plant just like these photographs suggest, lots of one species or lots of another species. Okay. This graph shows it quite dramatically that, in the early 70s, already there was an impetus that every piece of ground that was available to landowners, because they had the incentives of grants and tax benefits, to plant lots and lots of conifers. Okay, that changed, as you can see, gradually. Broadleaves pushed their way back in to the graph and into the UK. And then we have this produced by the Forestry Commission 2017. One of the three big risks to our woodlands, whether it's here or elsewhere, are those three items: pests and diseases, certainly, lack of species diversity, and wildfires. And so to conclude, this is what we all need in this room, what we need outside this room, and what we need globally. We need a bit of the old wood, and we need a bit of the very productive wood. They should marry up, and we'll all be very happy with that.
Okay, so I'm going to talk about the AA Zone Forest, Hook Park, and how we're approaching coming up with a long-term plan for the forest under an uncertain future climate. So if you don't know already, the AA owns Hook Park, which is a mixed species, 150 hectare forest in Dorset. And so you can see there in southwest England. And that's on the right, we have a map of the forest that shows the way the species are arranged. There's a lot of different species, but it's still dominated by beech, which is the dark green in the middle, and Norway spruce, which is the lighter blue around the edges. And the project that I've been working on for just under the past year is, as part of the Wood Lab research, is to come up with this 100-year, so long-term thinking, kind of long-term strategy for the forest. And Kate mentioned already a bit about why we're looking at this 100-year timescale, but it's trees that you're growing for timber take between 40 to 80, some even longer years to mature before you harvest them. So it's kind of ridiculous to think on a smaller scale than this anyway. And actually in Europe, there's a lot more kind of long-term 200, 300-year thinking. Also, as you can see on the right, and as we all know, the temperature, the climate is going to be quite different in 100 years' time, or even in one rotation time. So we need to think about how the climate is going to be then to help dictate what we're going to plant and how we're going to manage it now. So just to start off with, you could look at, how is the temperature going to change over 100 years? But actually, there's a lot of uncertainty and variation within this. So I've chosen this graph or this set of maps on the left just to show all the kind of the variation of possible, the range essentially of temperature increases. You've got like the most extreme, the top right. There's that's with a business as usual emissions pathway, and this is for the southwest, so it's including Hook. But essentially, that is actually not that useful for us right now when planning for the forest management to look at these temperatures and use these alone to dictate how we manage it. So actually what's more useful is to think about the abiotic impacts and the biotic impacts that climate change will have. So abiotic being the kinds of like the forest fires and the flooding, and biotic being the biological processes. So for example, this picture in the middle here it's not of Hook, thankfully, but it is a bark beetle destroyed forest in the Netherlands. And so the reason I've chosen this is because things like bark beetles, pests and pathogens will, their processes are temperature controlled, so they will expand their ranges and be able to be more dominant under climate change. And closer to Hook, well, this is actually a tree from Hook on the right that's been killed by squirrels. So grey squirrels are actually incredibly damaging to forests and also to Hook. And even their populations are likely to increase due to like milder winters. So this is obviously just a very brief kind of summary of some things that might happen, and we've looked at these a lot more intensely. There are some specific forestry tools that the Forestry Commission have set up that can help us try and kind of increase the likelihood of survival of trees under climate change. So this is the ecological site classification tool, which this one in particular has taken Hook Park and under a 2080 climate scenario, modeled how each species, and these are all species at Hook, might do. And just to highlight these 3 species here that are pretty dominant at Hook, and they're all looking quite, from marginal, which is like the yellow triangle, to red being unsuitable. Obviously, this is just a modeled kind of set of information. It shouldn't be taken as the only kind of truth, but it's important to consider alongside other research and analysis, and just kind of flag up some species that we might want to kind of try and diversify away from in some cases. There's another tool, which is the climate matching tool. And this, it takes the climate of Hook and it forecasts it. So this is on for 2080, and then finds all the areas in Europe that have this climate now. And the idea is it's about finding provenance. So trees that are grown, say for example that we want to continue growing oak, but we're worried about how climate resilient it is currently in the UK. We can find oak that's grown down on the west coast of France, for example, that might already be adapted to these conditions, or the predicted conditions. So it's kind of like giving evolution a helping hand. We're kind of getting something that's already evolved slightly or adapted to conditions, and the likelihood that they will have a better chance of survival. But ultimately, there's a lot of kind of system inherent invariability that we can't ignore, and foresters will have to make decisions that is based on incomplete information. So a much better way to go about it, well, the previous things I've discussed are important, but in addition, to think about it in a more holistic way, so in terms of ecosystem resilience. Resilience is a word that's often used and not really explained that well, so I'm just going to use this diagram to explain it a bit better. It generally means the ability of an ecosystem to absorb change and remain in the same state. So the red ball here is, for example, an ecosystem, and each cup is the different ecosystem states. Now, when the environment changes, it will move the ecosystem from side to side, and if the environment changes too much, it will enter a different state. And it might be that one is a woodland in a healthy state and one is a deteriorated state. They don't have to be a completely different type of ecosystem. So the depth of the cup represents resilience. So the deeper the cup is, the more likely the ecosystem is to stay in that state under environmental change. So the question here becomes, how do we increase the depth of the cup and the resilience of Hook? And the answer is really about diversity. And I'll explain how in a second, but just to kind of give you an idea of why diversity is so important in forests, are some of the most biodiverse ecosystems, and they're made up of lots of different organisms interacting together as part of a big network. And so the more kind of full that network is, the more likely if you remove one or two species, it can rearrange and then stay in the same state, which is really important. So how do we do this for Hook? What does increasing diversity mean? It doesn't just mean increasing the number of different species. That is important as well. But in addition to that, it's changing the way you manage the forest, so managing it in a more uneven aged way. So you have trees of different ages. So this diagram here shows a transition from a more even age to a more uneven aged management. So by providing different ages of trees, you're providing different habitats for species that will ultimately complete that network that's so important. You also need genetic variation so that when diseases come in, the trees are, the populations are better equipped to adapt and survive. And you also need diversity in within compartment and between compartment. So it's basically trying to have diversity on as many axes as possible. And that will also then give you a wider mix of species for the AA to use in terms of the produce as well. So it's essentially, we're trying to kind of optimize these three priorities. Obviously, biodiversity is so important, but we're still trying to produce timber, and we must have the forest be climate resilient. So increasing diversity helps all these three things, but in some cases there will be compromises that you have to make. So a timber species that is might not be that climate resilient, you might have to think about growing less of. And just to kind of come to an end now, this is just to give an overview of the kind of work we've been working on for the past year. So we started off by doing a kind of intensive baseline monitoring of the forest, because you can't really make a plan for it without understanding the health and what's going on now. And we've done a lot of research around it and kind of risk assessment of all the different options. We've compiled that into an input kind of evidence report, and then we're using that to write the next 10-year woodland management plan, which will come into place next year. And then we're at the same time kind of compiling all these themes and ideas to put together a more kind of broad and long-term 100-year plan, which takes into account all of these key themes on the right-hand side here, to hopefully leave us with a biodiverse, multi-purpose, resilient forest for more than 100 years.
Got time to take any?
I think we don't have time for questions. But I tell you what, Mike suggested that we all go and hang out in the bar for questions if anyone wants to find us, because I think we've got the next group knocking on the door. Apologies, we started a bit late. We had an interesting journey from the park this morning. Thank you.